Yep, so I'm Jordan, and this is the project I did last summer through the Palace undergrad bursary scheme. So starting off with what seeps are, because I know a lot of you haven't heard about these. These are deep water habitats along continental plate margins, several hundred, several thousand meters below sea level, where we have methane and sulfides slowly seeping up from the seafloor, hence their name. And these sites are dominated by bivalves and tube worms, which have chemosymbiotic bacteria in their gills, which can oxidize the reduced sulfur in order to fix the carbon for their hosts. And seeps also contain many gastropods, such as sea snails and limpets, which graze on bacterial mats found at these sites. So, like the title said, I looked at Caribbean fossilized seeps, which are usually around late Eocene to Miocene in age, and you can see the position of Barbados and Trinidad in relation to the rest of the South Caribbean. Now, these specimens were first described in 2005, but discoveries from Japan, Antarctica, and New Zealand and elsewhere since that time have called into question the original taxonomic identities of the fauna, which is where I came in to reanalyze the taxonomic affinities of these fauna. And what makes the Caribbean so interesting is it has a range of different geologies, such as Barbados has macritic and sandy limestone, as well as oily mudstone, and Trinidad contains white clay-like limestone, which are all believed to have different faunal assemblages. And so starting off with the gastropods, I looked at about 300 specimens in total over summer, and I managed to deduce 17 species were present, and 14 of them we think are new to science. And there was a relatively wide variety of families, which is quite unusual for seeps. And these include Neretids, turbinids, so this is a silicon rubber cast, and several limpets. And so, again, this high diversity is quite unusual for seeps. But the most interesting specimens were these two high-spired gastropods. So this is Hydroconcha, and this is Escherichia. And these two belong to a family which has never been found outside of the Mesozoic. So appearing in Miocene seeps is quite a surprise, and this could change our understanding of this habitat's evolutionary history regarding why were these so far out of the previously known time range. And moving on to bivalves, I looked at about 250 specimens for these and found 21 species again, and believe 10 of them are new. And again, we have a large variety of families such as Lucinids, Thiosauриds and Vesicomyids, so again this is high diversity. And again, the two most important specimens are these two. So these are Vesicomyids, same family, but these ones are about 20 centimeters long. That's only two. And what makes them interesting is usually the Vesicomyid family has teeth in their hinge, whereas these are edentulous either at the adult life cycle or their entire life cycle. And so this warrants the creation of a new genera for each specimen, again increasing the diversity. And so carrying on with bivalves, I also looked at a few specimens from Peru, which are believed to be around the same age. And I hope you can appreciate these two look quite similar to the ones I've shown on the last slide. And so we believe they are within the same genus at least, and so this could raise the possibility that these animals over ecological and evolutionary timescales could easily move between the Caribbean and the Pacific. However, at a generic level, these specimens are never found beyond the early Pliocene, and early Pliocene molluscs are never found, recent molluscs are not found, they don't have a pre-Pliocene fossil record. And so nothing's conclusive, but the time range at which this occurs is coincident with the closure of the Isthmus of Panama. And so we could maybe speculate, at least, and hopefully we're going to more likely conclude that the closure of the Isthmus of Panama had a significant role in shaping seep biogeography. And that's where my project ends. So thank you for listening.